Welcome back to the Deep Dive. Our mission today, we've got this stack of regulatory stuff, global rules, labels, risk assessments. We want to give you the ultimate shortcut to understanding, well, the pretty complex world of chemical safety. So if you deal with anything from industrial solvents to, say, advanced pharma ingredients, this is definitely your deep dive.
Yeah, this area is absolutely crucial for trade, for protecting people. But the jargon, I mean, it's legendary, right? We're here to try and decode some of that. The big challenge, really, globally, is finding that balance. The huge benefits chemicals give us versus the potential for, well, serious harm to people and the environment.
And you just can't regulate every single chemical one by one. It's impossible. So we have to build systems. And the main aim, the fundamental goal of all these big international rules, whether it's REACH in Europe or the UN's global standards, it's actually quite straightforward.
It is. It boils down to protecting people, protecting life, really, from the risks when chemicals aren't handled right. And to do that, we lean on two massive pillars. First, getting the language of danger consistent, that's classification. And second, structuring how we control things, managing those risks once we know what they are.
Okay, let's unpack this then. Starting with that global push to make chemical labels look the same everywhere. That's quite a story, isn't it? Harmonizing trade.
Oh, absolutely. Historically, it was a bit of a mess. If a company, say in North America, wanted to ship to Europe, they often had to completely redo the classification, stick new labels on everything because what flammable meant here might be different over there, or toxic.
Total nightmare for business, a real bottleneck.
Exactly. So the UN stepped in, and they created what's basically a global agreement for chemical labels, the Globally Harmonized System of Classification and Labeling of Chemicals, GHS. It gives everyone a consistent way to figure out a chemical's basic inherent dangers.
Right, and here in Europe and Great Britain, those GHS rules, they come to life through CLP, classification, labeling, and packaging regulation. That's the law behind those diamond symbols you see, maybe on your cleaning spray bottle.
And feeding into all this, you've got the sort of the big one for European chemical control, REACH, registration, evaluation, authorization, and restriction of chemicals. Think of REACH as this huge rule book that basically says, if you want to sell a chemical here, you have to show you understand its risks and you're managing them properly.
But wait, you mentioned REACH, and this is interesting from the sources. It's not just about commerce. There's this sort of ethical angle tucked away in there, promoting alternatives to animal testing. How does that actually work?
It's quite powerful, actually. The regulation pretty much forces industry to check for existing reliable data first. When you're classifying a hazard under GHS, it's like 3 simple steps. Find the data, review it, decide if it's hazardous. And the sources point out that GHS specifically says, yes, use reliable human data if you have it, maybe from past exposures, or existing non-animal test results. This cuts down the need for new animal tests, which are expensive and, well, controversial. It's kind of efficiency meeting ethics.
Okay, so the hazard's identified. Now the job falls to the manufacturer or the supplier using those CLP rules. They have to communicate that danger clearly to whoever's using the chemical. And this classification looks at, what, 3 main risk areas?
That's right. Physical properties like, is it explosive, flammable, then health effects, toxicity, things like that, and environmental effects.
And this is where it gets visual, right?
Yeah.
On the label itself.
Exactly. The hazard gets translated directly onto the label through these standard mandatory things. You've got the supplier's details, the product name, and crucially, those hazard pictograms, the diamond symbols, everyone should recognize.
Plus the signal words. You'll see either danger for the really serious hazards or warning for the less severe ones. But the nitty-gritty details, the specifics, they come from those letter and number guns.
Ah, yes, the H statements and P statements. Think of them like super short safety instructions. The hazard statements, the H numbers tell you exactly what the danger is. For instance, H301 just means toxic if swallowed. Simple as that. It's the nature of the risk.
And the P numbers, the precautionary statements, they're the what to do or what not to do.
Exactly. They're the advice, how to prevent harm. So P102 might be keep out of reach of children.
So the label gives you that quick alert, but for the full picture, the whole story, you need the safety data sheet, the SDS.
Precisely. Suppliers have to provide these free for anything classed as dangerous, and they need to keep them up to date.
And that SDS is the ultimate guide, isn't it? It's got those 16 mandatory sections. It tells you everything. First aid, what happens if you spill it, what gear you need.
Absolutely. It's the user's complete manual for safe handling. It takes you beyond just spotting the danger to really understanding the risks in context.
Okay, this is where it gets really interesting for me. Let's look at what those health hazard symbols actually mean. starting with acute toxicity, the immediate danger stuff.
Right, acute toxicity. That's the risk of getting seriously ill, or worse, from a very small dose, usually after just one short exposure. GHS ranks this risk in categories. The most dangerous ones, categories 1, 2, and 3. They get that very clear, very regulated symbol, the skull and crossbones, and the signal word is danger.
Okay, stark warning. What about the exclamation mark? That seems to be everywhere.
Yeah, the exclamation mark is for, let's say, slightly less severe immediate dangers, things like skin or eye irritation, or category 4, acute toxicity stuff the system calls harmful, rather than immediately fatal or toxic at low doses. The key thing for you to remember, though, is even these substances, the ones with just the exclamation mark and warning, they are still toxic. You still need to be careful.
Got it. Okay, let's talk about things that, well, damage you on contact. Corrosive versus irritant. What's the real difference there?
The big difference is irreversibility. Is the damage permanent? Corrosive substances, often strong acids, strong alkalis, cause irreversible tissue damage. Necrosis. It eats through the skin layers. That gets the corrosion symbol, that picture of something eating into a hand and a surface.
So irritant is the less severe version of that?
Exactly. Irritant causes reversible damage. Things like temporary redness, inflammation, maybe temporary changes to skin or eyes that will heal. Irritants get the exclamation mark. And often the key difference is just concentration. You might have a neat acid that's corrosive, but dilute it way down, and maybe it's only an irritant.
Right. Now, the one that always looks the most serious in the health category, the health hazard symbol, GHS08, the exploding chest one. If you see that, you know it's something critical long-term, systemic.
Absolutely. That symbol signals the major, often delayed, health threats. It's used for respiratory sensitizers, things that cause occupational asthma. But critically, it flags up genetic and reproductive harm. We're talking germ cell mutagens, chemicals causing DNA changes in sperm or eggs that can be passed on, and reproductive toxins, things affecting fertility or harming unborn or breastfed children.
And perhaps most seriously, it's the main symbol used for carcinogens, cancer-causing substances.
Yes. Carcinogens work by changing a cell's DNA, triggering abnormal cells that just divide uncontrollably. What makes them especially frightening is the latency, the time lag. The effects are irreversible, but the cancer might not show up for 5, 10, sometimes even 50 years after you were exposed.
And the sources really hammer this home.
Yeah.
For carcinogens, there's a critical implication that changes everything for risk assessment. There's no safe level, no threshold of harm. Any exposure, theoretically, has the potential to cause cancer.
Exactly. And that dictates a completely different, much tougher standard for control. Which brings us neatly on to risk management.
Right. So employers have a legal duty. They must do a risk assessment if work could expose employees to hazardous substances.
Yeah.
And it's not just a one-off thing, right? It needs reviewing.
Definitely. You have to review it if you suspect it's no longer valid. Maybe workers are complaining about symptoms, maybe the process changes significantly, or if there's an accident or incident, that's a clear trigger.
Okay, the assessment process itself generally involves steps like gathering info, evaluating risks, deciding controls, recording it, reviewing it. But when you're evaluating that risk, what specific factors really matter? What affects how much exposure someone actually gets?
Well, you have to think about how it can get into the body, the routes of entry. Inhalation is a big one, breathing in vapors from liquids, especially if they're heated, or dust from powders. Then there's skin contact, ingestion maybe transferring from contaminated hands, and even penetrative injuries like needle sticks. You also have to consider mixtures. Sometimes chemicals together have additive effects, or worse, synergy.
Synergy, meaning they're worse together than apart.
Yeah, the combined toxicity is greater than just adding up the individual toxicities. That can be really tricky.
And what about the workers themselves? People aren't all the same. Susceptibility varies.
Hugely important point. You have to consider vulnerable groups. People with existing conditions, like atopic individuals prone to asthma. Women of childbearing age regarding reproductive toxins like lead or mercury. Those often carry the H360 hazard statement. Younger workers need extra consideration too, as their bodies are still developing. And anyone already sensitized to something, maybe flour dust or cement in construction.
Okay, so let's talk control standards. For most chemicals, control is considered adequate if you stay below the occupational exposure limit, the OEL. But you said the bar is higher for those really nasty ones.
That's right. Because of that no safe level concept for carcinogens, mutagens, and asthmagens, the aim isn't just to meet the OEL. The legal requirement is tougher. Exposure must be reduced to the lowest level reasonably practicable LRRP. That forces a much more rigorous, systematic approach to control.
And that systematic approach is laid out in, well, a really critical tool, the hierarchy of controls. It ranks safety measures by how effective they are. You always start at the top.
Always start at the top. The most effective, most reliable method is elimination. Can you just get rid of the hazardous substance altogether? Like switching from a solvent-based paint to a water-based one. Simple as that, if possible.
Okay, if you can't eliminate it, step 2 is substitution.
Right. Swap it for something less hazardous, maybe a chemical with a lower hazard class, or change its form, like using solid pellets or granules instead of a fine, dusty powder. Think ceramic glazes granules are much less likely to become airborne.
Makes sense. Next down the list is good design and enclosure. Engineering it out.
Correct. Containing the hazard. Maybe automating a process with robots inside an enclosure, or just designing the tasks to create less of the hazard in the first place, like using a brush to apply something instead of spraying it.
After containment, we hit engineering controls. These are probably the most common ones people think of.
Often, yes. This is your local exhaust ventilation LEV sucking the fume or dust away right where it's made. Or maybe dilution ventilation, using airflow to reduce the concentration in the general air, usually for less toxic things. Still not enough. Then we move to work systems, changing how people work.
Yeah, these are procedural or administrative controls.
Yeah.
Things like limiting exposure time through job rotation, minimizing the number of people near the hazard, banning eating, drinking, or smoking in work areas where contamination could happen.
And only then, right at the very bottom, the last resort, personal protective equipment, PPE.
Exactly. PPE respirators, gloves, eye protect. It's the final line of defense. It should only be used after you've done everything else higher up the list, as far as you reasonably can. And this is so crucial. PPE relies entirely on being used correctly. If a mask doesn't fit right, if a glove gets a hole, it fails. And it fails to danger.
Wow, we've really covered the whole journey there. From the UN, getting everyone on the same page with GHS symbols, all the way down to that strict legal duty on employers to follow that hierarchy step by step. Hopefully you listening can now look at a chemical label and have a much better sense of the real risk it represents. I think the real takeaway is learning to read the codes. Understanding that seeing, say, the GHS08 health hazard symbol, the one for carcinogens or mutagens, understanding that instantly changes the game. The control needed shifts from just adequate up to that much higher standard, lowest level, reasonably practicable. Knowing that helps you become an informed voice for safety. Realizing hazard control is this whole system, this layered approach, not just, grabbing a mask.
And that leaves us with a final, maybe slightly unsettling thought for you to mull over. We talked about how the effects of the worst hazards, like carcinogens, might not show up for decades, 5 years, maybe 50 years later, given that incredibly long latency period. How does that delay really challenge our ability to know if the controls we put in place today are truly effective? It suggests we might not actually find out if we got it right until, well, potentially the next generation of workers starts showing symptoms.
A sobering thought to end on. Thanks for diving deep into the regulations with us.
We'll catch you next time for the next deep dive.